Okay, so this is going to be the quiz review homework that we're going to have a quiz on April 16th for. So these are the sheets that were handed out to you. We'll go ahead and just knock them out real quick. So this one right here, we got to keep in mind this is asking for us to simplify to the nearest tenth. So one of the things that we have to look at is we have to take what we're looking for, which is the square root of 18, and we're going to look for the perfect square that is above and the perfect square that is below this. Okay, well, the perfect square that is below this is going to be the square root of 16, which is going to be 4, and the one that's above it is square root of 25, which is 5. So as we look, 18 is 2 away from 16 and is 7 away from 25. So this value right here is going to be closer to 4 than it will be to 5. So we are going to approximate that the value is going to be approximately 4.2. Okay, so let's look at the square root of 20. Okay, again, the square root of 20, our perfect square above it is going to be the square root of 25, and the square root below it is going to be the square root of 16, which is 4 and 5. And so again, if we were just kind of looking at this as a number line, actually let's kind of draw a nice neat line there. So if we were looking at this like a number line, we would see that we are closer to this 5 than we are to the 4. So I would guesstimate, actually, we're closer to the 16 than we are to the 25, so it's probably going to be around a 4.4. Okay, square root of 45, we have the square root of 45. And on this side, we have the square root of 49. On this side, we have the square root of 36. Again, our number line tells us that we are, square root of 36 is 6, square root of 49 is 7. We are 9 away from 36, and we are 4 away from 49, so we're going to guesstimate around 6.7. And the last one, square root of 32. Above it, we have the square root of 36. And below it, we have the square root of 25, which is 5 and 6. We are closer to the 36 than we are to the 25, and we're probably around a 5.7. Okay, so these are your answers for the first page. Alright, so perimeter. Perimeter is just basically taking the sum of all of the sides. So in this first example right here, we have a triangle. We know all 4 sides, or all 3 sides, sorry. So we're going to approximate our value of square root of 7. So if we have the square root of 7, we're going to approximate this value, and again, we're going to look at our perfect squares above and below, okay, which is going to be 2 and 3. We are closer to the 9 than we are to the 7, so we're going to approximate this to 2.6. If you have a 2.6 or 2.7, that's fine. But we know that it's not 2.5, and we know that it's probably not closer to 2.8, 2.9. All right, if we look at the square root of 5, again, above is square root of 9, below is square root of 4. We have a 2, and we have a 3, so we're definitely closer to the 4. So we're going to estimate this at 2.1. So we know that the square root of 7 is approximately 2.6. the square root of 5 is approximately 2.1. And so when we add all three sides together, we're going to have 3.2 plus 2.6 plus 2.1. And when we add those together, we're adding our whole numbers. 3 plus 2 plus 2 is 7. 2 plus 6 plus 1 is 9. Okay, so this one, again, since we have only two sides, we can naturally assume that the opposite side is the same as each other. Okay, or we know that the perimeter is equal to 2 times the length plus 2 times the width. Okay, so first let's go ahead and look at approximating this square root of 10. Alright, square root of 10, above it is square root of 16, below it is square root of 9, which is 3 and 4. We're closer to the 9 than we are to the 16, so we're going to estimate this at 3.1. So if we take our perimeter formula, we have P equals 2 times the length, we'll say is 4, plus 2 times the width, which is 3.1. So we have 8 plus 6.2, which would be equal to 14.2. Okay. So here we have a ladder that is standing up against the house. The base of the ladder is 6 feet from the base of the house. So we just kind of draw a little picture here. We have this house. Yep. Okay. Not a very nice house, but then we have the grass that's right there, and we have this ladder. All right. And it says that the ladder is 15 foot, and the base of the ladder is 6 feet from the base of the house. So the base of the ladder is 6 feet away from the base of the house. So we can see here that we really kind of have a right triangle, where our hypotenuse is 15, and then A or B is going to be equal to 6. So the Pythagorean theorem is A squared plus B squared equals C squared. So our C is our hypotenuse, which is 15, and we know that because it's the longest side, or the side that is opposite of the right angle. So we have 15 squared equals x squared plus 6 squared. So we get 36 plus x squared equals 15 squared is 120. I'm sorry, it's 225. Okay. So then we subtract 36 from both sides, and we're left with x squared equals 185, or 189, sorry, 189. So now, if we have x squared equals 189, in order to get rid of this square, we take the square root of both sides. We take the square root of a square, they cancel each other out, and we're left with the square root of 189. Now, in order to go ahead and figure out on the calculator this square root of 189, you do have a, let's see here. So you have this second function. Okay, if I'm looking at a graphing calculator here, okay, we have second for the square root, and we're going to take 189, close the square root, and we're left with 13.74. Okay. So we have 13.74. Okay. Again, with these right here, we know that the square root of 16 has a perfect square. That's 4. 20 does not have a perfect square. So we can either go ahead and, since we know that it does not have a perfect square, we can use our factor, and we have 5 times 4, and we have 2 times 2. So our prime numbers, when we rewrite this as the product of the primes, we have 2 times 2 times 5. So when we know this, if we have the pair of the same number, we move 1 to the outside, and everything else will stay inside. We have 5. Now, this is how we've been doing it, and it's also kind of a fail-safe system as long as you just make sure that you write out your product of the primes here at the bottom. However, sometimes it's a little bit easier if we recognize that we're looking for the largest multiple of our radicand, which is 20 here, that has a perfect square. So our largest multiple of 20 that has a perfect square is 4. And when we multiply that by the square root of 5, we're left with the square root of 20. But we know that the square root of 4 is 2, multiplied by the square root of 5, and we get the same answer as we had down here. So for the square root of 8, the largest multiple that is a perfect square of 8 is 4 times the square root of 2. Square root of 4 is 2 times square root of 2. Okay. For 80, and again, sometimes it's not as easy to figure out, okay, what is my largest multiple here? All right. So let's do a factor tree. I have 80, and we'll say 20 times 4, and we see that we have a 2 and a 2, and we have a 5 and a 4, and we have a 2 and a 2. So our product of the primes is 5 times 2 times 2 times 2 times 2, because we have 1, 2, 3, 4 2's, and so when we look at this radical, we have a pair of 2's, we move 1 to the outside. We have a pair of another 2's, we'll move another 1 to the outside, and what we have left we'll leave underneath. So you have 4 square root 5. All right. So the largest multiple of 32 that has a perfect square is 16. The square root of 16 times the square root of 2 is going to equal square root 32. We know that the square root of 16 is 4 times square root of 2. That's going to be our answer here. And then 125, we have the square root of 25 times the square root of 5. That equals the square root of 125. The square root of 25 is 5. And we multiply that by the square root of 5. That's going to be our answer. Okay, so here we have to add these together. However, you look at what our radicands are, most of them are going to require simplification. So because we have like radicands on this situation right here, we can add our coefficients. So we have 3 plus 3, which is 6, square root 18, which is the same thing as saying 6 times the square root of 18. But this can be simplified. The square root of 9 times the square root of 2. And we still have this 6 here. So we have 6 times square root of 9 is 3 times the square root of 2. So we'll have 18 square root 2 for this first answer. For number 15, we're going to kind of break it up. The first section is we have 3 times the square root of 45. The largest multiple of 45 that has a perfect square is 9 times the square root of 5 times 3. So we have 3 times square root of 9 is 3 times square root 5. So this is simplified to 9 square root 5. Now we have this 2 times the square root of 20. Largest multiple of 20 that has a perfect square is 4 times square root 5. Square root of 4 is 2. So then we have 4 square root 5. Now when we add them together, we notice we have like radicands. So 9 plus 4 is 13 square root 5. Okay, for the last two here, we have 3 times the square root of 24. Largest multiple of 24 that has a perfect square is 4 times square root 6. And then we have this 3. Square root of 4 is 2 times 3 times square root of 6. So we have 6 square root 6. Next we have 2 times the square root of 54. Largest multiple of 54 that has a perfect square is going to be 9 times square root 6. We have this 2 times. The square root of 9 is 3. 2 square root of 6. So we have 6 square root 6. When we add them together, we have like radicands, which is 6. So 6 plus 6 is 12 square root 6. Okay, and then for our last one, we can't simplify this, but we can with this 27. We have 3 times square root 27. Largest multiple of 27 that has a perfect square is 9 times square root 3 times 3. Square root of 9 is 3. And then we bring this 2 square root 3 down. So we have 9 square root 3 plus 2 square root 3, which equals 11 square root 3. Okay, so for our missing sides of the triangle, we recognize that because this 5 is the longest side and across from the right angle, this side is equal to C. It doesn't matter the other sides, whether they're A or B. So we have x squared plus 3 squared equals 5 squared. A squared plus B squared equals C squared. So we have x squared plus 9 equals 25 We subtract both sides by 9, and we're left with x squared equals 16. To get rid of the square, we will take the square root of both sides, and so x equals 4. Okay, so again, we know that this is our hypotenuse. So we have 12 squared plus 5 squared equals x squared, which is 144 plus 25 equals x squared. So here we have 169 equals x squared. Take the square root of both sides. X equals square root 169. And when we come back over here, we'll clear this out. We have second square 169. And so our answer is 13. Final slide. We know that this is our C. So we have 14.2 squared equals x squared plus 8 squared. So we come back here to our calculator. We can say 14.2, and that's going to be raised to the second power for squared equals 201.64 equals x squared plus 64. Subtract 64 from both sides, and we have x squared equals 137.64. Take the square root of both sides, and x equals second square root 137.64, and we're left with 11.7. Okay. Alright, we will see you tomorrow. We're going to skip this one for tonight.